Imagine stepping into the future. You walk into a new kind of airport, one that feels almost surreal. The air is calm, and there's an unusual silence. There's no thunderous roar of jet engines, no heavy stench of burning fuel, and none of the chaos of endless boarding lines. Instead, in the middle of the runway, a sleek silver aircraft with the Tesla logo gleams under the soft morning sun. It looks like something designed for another planet, aerodynamic, elegant, and futuristic in every sense. A smooth sliding door opens without a sound, revealing a minimalist interior illuminated by soft ambient light that feels both calming and advanced. The seats look like they belong in a spaceship. Everything inside seems to blend cutting-edge design with sustainable simplicity. Then, without a single blast of noise or the usual vibration of turbines, the aircraft lifts vertically into the air. There's no smoke, no fuel smell, no pollution, just pure electric propulsion. What was once a dream or a sci-fi fantasy has now become a reality. In 2026, Elon Musk shocked the world by unveiling the Tesla super electric plane, a creation that many experts once deemed impossible. But this isn't just another high-end project for the wealthy. It's not a $10 million private jet or an experimental prototype. It's the world's first mass-market electric aircraft. And the most astonishing part? Its price tag, only $79,797. That's right, for less than the cost of a Porsche. Tesla has built a machine capable of flying 1,200 miles on a single charge, recharging in minutes, and transforming aviation as we know it. This marks the end of the jet fuel era and the beginning of what Elon Musk calls the electric sky revolution. It's a moment that signals the future of flight clean, quiet, and accessible. But how did this even happen? For decades, aviation experts claimed electric planes were impossible. The problem wasn't the aircraft design, it was physics itself. Jet fuel contains enormous energy density, far greater than what any battery could provide. Airplanes need an incredible amount of energy just to lift off the ground, let alone sustain long-distance flight. And for years, that challenge kept electric aviation trapped in the realm of imagination, even as Tesla transformed the automotive industry. Most engineers laughed whenever Musk mentioned his dream of electric flight. Back in 2010, Musk tweeted about sketching designs for a supersonic electric jet, and the internet rolled its eyes. In 2013, he talked about how a battery with the right energy density could make electric planes possible. And once again, critics dismissed it as science fiction. To be fair, at that time, the technology truly wasn't there yet. Tesla's most advanced batteries in 2013 had an energy density of around 250 watt-hours per kilogram, powerful enough for cars, but nowhere near the 400 watt-hours per kilogram needed for a long-range electric plane. So while others in the industry, Boeing, Airbus, and dozens of startups dismissed the idea, Musk quietly waited, planned, and invested in the future of batteries. And then, as history shows time and again, Musk's persistence began to pay off. Tesla's Battery Day announcements revealed the game-changing 4,680 cells larger, denser batteries that drastically reduced weight while boosting range and efficiency. This was followed by breakthroughs in solid-state battery chemistry, allowing faster charging and higher safety. But the real revolution came with Tesla's aluminum-air battery technology, a system that used oxygen from the air to generate electricity, reducing the weight problem that had haunted electric flight for decades. By 2026, Tesla had finally cracked the code. With aluminum-air batteries integrated into Tesla's structural airframe design, the dream of electric flight was suddenly real. Musk knew it was time to reveal what he had been working on in secret. And the stage for this revelation couldn't have been more perfect. The unveiling didn't take place at an auto show or even a traditional air show. Instead, it happened at Giga Texas Skyport, Tesla's newly built vertical airport right next to its Austin headquarters. Thousands of fans, reporters, engineers, and aviation experts gathered, expecting a concept model or maybe a flight demonstration. No one knew that what they were about to see would rewrite the rules of aviation forever, as the crowd buzzed with anticipation. Elon Musk walked out with his characteristic half-smile and said just 6 words that would echo through history. The future of flight has arrived. The giant hangar doors began to slide open, revealing a glimmering silver aircraft. The crowd went completely silent. Before them stood something unlike any airplane ever built. The Tesla super electric plane looked like the perfect blend of a private jet, a drone, and a spaceship. The body was sculpted with flawless aerodynamic curves. The wings were smooth and retractable, folding neatly into the fuselage when not in flight. Vertical rotors were hidden within the body, capable of allowing vertical takeoff and landing, no runway required. The iconic glowing Tesla logo shone faintly on the nose, symbolizing not just a brand, but a movement. Musk paused for a moment, letting the audience take it all in, and then dropped the bombshell. This is not a prototype. This is a production-ready Tesla aircraft. Gasps filled the air. This wasn't just another futuristic concept meant for the stage. It was a fully functional, market-ready machine. And Tesla was already preparing for mass production, Musk explained. How this plane had been engineered from the ground up using Tesla's most advanced materials and manufacturing techniques. The body was made from ultralight, carbon aluminum composites that were both stronger and lighter than traditional aircraft materials. The wings housed retractable electric rotors for vertical lift, powered by Tesla's next-generation solid-state batteries, while the main body held the long-range aluminum air cells that provided the extended flight capacity. This combination allowed the plane to take off vertically like a helicopter, fly horizontally like a jet, and land almost anywhere, eliminating the need for runways entirely. The energy efficiency was staggering, less than 1/5 the cost per mile of a conventional private jet, and almost silent during operation. Inside, the aircraft's cabin was pure Tesla minimalism: smooth white surfaces, adaptive smart glass windows that adjusted transparency with sunlight, and seats embedded with Tesla's biometric comfort systems. Passengers could control cabin lighting, entertainment, and even climate settings through neural-linked voice commands or Tesla's onboard AI assistant, powered by the same Grok neural network used in Tesla vehicles. But beyond the luxury and design, the biggest achievement was performance. The Tesla super electric plane could travel up to 1,200 miles. On a single charge, enough for regional and even intercontinental routes. The recharge time was equally astonishing. Less than 30 minutes using Tesla's high-capacity Skycharge system, which used solar-powered solid-state battery docks built into every Tesla Skyport, and for longer routes. Tesla designed modular battery swapping, a technology Musk had shelved years earlier for cars, but revived for aviation. With it, planes could land, exchange depleted modules for fresh ones, and be airborne again in minutes. The price point, however, was what shook the world. For $79,797, anyone could own what was once reserved for billionaires. Musk's plan wasn't to compete with private jets, it was to democratize flight, to create an aircraft that middle-class families, regional transporters, and even small businesses could afford. It was, as Musk called it, a Model 3 moment for the skies. The aviation world erupted. Traditional manufacturers like Boeing and Airbus faced an existential crisis. Airlines saw their business models threatened by direct-to-consumer air travel. Even governments began reconsidering infrastructure. Why build more airports when vertical skyports could replace them? Environmentalists praised the move as revolutionary. With zero emissions, nearly silent operation, and full recyclability of its battery materials, the Tesla super electric plane became the most sustainable aircraft in history. Musk even revealed plans for autonomous flight, allowing these planes to operate without pilots on specific routes, controlled by Tesla's advanced autopilot system connected via Starlink satellite networks. And speaking of Starlink, this aircraft was fully connected to it. Every passenger could enjoy ultra-fast satellite internet anywhere in the world, turning every flight into a seamless workspace or entertainment hub. The plane also featured AI-assisted safety, 360 obstacle detection, and quantum encryption for communication security. Critics who once mocked Musk's electric plane dreams suddenly found themselves rethinking the future of aviation. The ripple effects spread across the industry. Oil companies felt the pressure of reduced jet fuel demand. Airlines began exploring Tesla partnerships to electrify their short-haul fleets. And smaller nations began planning Tesla Skyports instead of traditional runways. It wasn't just an aircraft, it was a complete ecosystem. Tesla's vision combined clean energy, autonomous technology, and vertical mobility into a single network that could power the next century of human transportation. And when Musk was asked what inspired him to finally bring this vision to life, his answer was simple. Humanity wasn't meant to crawl across the earth. We were meant to soar sustainably. As the Tesla super-electric plane lifted into the sky at the end of the event, hovering silently before accelerating into the clouds, the crowd erupted into applause. It wasn't just witnessing a product launch. It was witnessing history,